Hello everyone. Let us try to understand what is the longest increasing subsequence. After that, we'll see four different ways to find longest increasing subsequence. First way, let's name it DP method, that is, let's say DP1, and it's a very standard solution, right? We all must be aware about it. Second should be the DP2 solution, right? So this is not so standard solution and it's quite tricky to understand, but we'll try to understand in a best possible way, right? After this, we'll modify this dp2 method, right? And we'll see some observations in dp2 method that will lead us to dp3 with binary search. Basically, let's not write it dp3, let's write it dp2 only. The third method will be dp2 with binary search, right? We'll note some observations in dp2 method and then we'll try to optimize. Fourth method that we'll see is using dp with segment trees. Okay, so I'll try to code all possible. I'll try to make you first understand each of these solutions and then we'll try to code them as well, right? Okay, so let's begin. So guys, I hope you all are aware of what is longest increasing subsequence. Basically, you are given an array, right? You're given an array and in that array you have to find a subsequence such that it is the longest increasing subsequence. That means that, let me just give you an example. 1 5. Okay, right. What should be the longest increasing subsequence of this array? Think about it, pause the video, right? What does the longest increasing subsequence mean? That it's a subsequence. First of all, you know what is a subsequence, right? There are 2 to the power n possible subsequences of for an array, including the empty subsequence, right? And the longest means that its length should be the longest, and increasing, it should be strictly increasing for now, right? Let us consider strictly increasing for now. After that we can easily modify it by some minor changes, right? First of all, what is the subsequence? It should be longest and it should be increasing. These three conditions should be satisfied, right? So let's say if I make a subsequence 1 2 3 4 6 and 10. What is the length of this? See, 1 2 3 4 6 and 10, right? What is the length of this? 6. I can also make 1 5 9 and 10. Length is 4, right? I'm making increasing subsequences. Just I can also make 1 2 3 4 9 and 10, right? Again length 6. So in the end what we have to tell is the length of the longest increasing subsequence. And it's also we can also find out what is the length of the longest increasing subsequence by traversing back, right? So first of all, I hope you got this. What does the question demand, right? And it's a very famous topic, you must have all heard about it, right? So let's pause the video and think about the solution first. First of all, I'll begin with the most easy solution, that is, find the LIS in O of n square using dynamic programming. Okay, right. So what I'll do is, let's make a dp array and let's name its state as the dpi equals to length of longest increasing subsequence, including or let's say ending at I, right? So dpi represents the length of longest increasing subsequence ending at I, right? So guys, let's try to make it work on the above example. 1 5 2 3 4 9 6 and 10, right? 1 5 2 4 5 2 3 4 6 and 10. So basically let's say I'll make a DP array for every I position, right? Right. So guys, if I want to find the length of longest increasing subsequence ending at I means I have to include that element, right? Basically I have to include AI, right guys? What should be my recurrence relation to find this DP? So DPI, it's very easy to see one thing, that for any element, if I include that element, what I need is I want the previous best endings, right, for all the numbers that are smaller than AI. Basically if I talk about this 3, let's talk about this 3, right? What does this 3 want? That what is the best ending position that ends at 2, and what is the best ending that position that ends at 1, right? Because when I have these two best endings, then only I can add 3 behind them, na? Right? Because 1 and 2 are smaller than 3, right? Basically try to understand it, that what I need is I have to find the length of the longest increasing subsequence. So if I include 3, then 3 can be included after 2, and it can also be included after 1. So after which will I try to include it in my subsequence? I'll try to include it after the one that will give me the best ending, the maximum ending, right? Because now this 3 has various choices. Okay, let's talk about this 9. So guys, 9 can be added after 4, after 3, after 2, after 5, and after 1, right? Because 9 is greater than all of them, right? So if I say that there is an ending at 3 with some length, that means I have ended that sequence with 3. So after this 3 I can add 9, right? Same for 4, same for 2, same for 5, and same for 1, right? So basically what does an element need? An element needs that to the left of it, how many elements are smaller than that element, and which element gives me the best ending out of those smaller elements, right? So basically let's talk about say 6 again. 6 won't give me a good example. Okay, let's talk about this 5. So 5 can be included after 1, right? And let's talk about this 2. So 2 can only be included after 1, right? Why? Because only 1 will give me the best ending, and it is smaller than 2, right? So out of all the numbers that are smaller than a current element, I want the one that has the maximum ending at that position. That means the maximum value of DPI, right? Okay, so right, so let me just write the recurrence relation over here. Basically DPI equals max of DPJ, right? Where J is less than I, first of all, right? And AJ is less than AI, right? Now if I will add the current element after all those positions, the maximum of all those positions, then what I need is plus 1. Why this one? Because I am adding the current element to that length at DPJ, right? So let me just run it over this example, and then you'll easily understand what does this mean. So initially all the DP values are filled with 0, right? So guys, what is the best ending at index 0? That is at 1. It will be 1 itself, because see, how many j are less than I? There is no j that is less than I, right? Currently I am on index 0. So if there is no j, that means the maximum length that I have till now is 0, right? So I can add that length, I can add this one after that length. This will give me one length, right? Okay, now guys, let's talk about this 5. For this 5, how many j's are there that are less than I? 0 only, right? Because 1 is over here. Let me write it. Okay, 0 only. And is second condition also satisfied, that aj should be less than ai? Yes, it should be satisfied. It is satisfied, right? So what I'll do is, there's only one option, the maximum of that is one only, right? This one. Now, because one length I'm talking about, not the element one. So this 5 will give me the answer as 1 plus 1, that is 2. Right guys, and you can easily see that if I end at 5, I'll have the maximum length to be 2, right? Okay, so let's talk about the element 2 and the index 2. Okay, so guys, for index 2, how many j's are less than this 2? That means after which element can 2 come, that element should be on the left of 2, and also that element should be less than 2, and that element should give me the maximum ending. Okay, these are the three conditions that are required. So it can come after this one only, right? It cannot come after 5, because 5 is greater than 2. Basically I have the max as 1 only, right? So 1 plus 1 is 2, right? So the best ending at 2 is 2. Again guys, at 3, what is the best ending? For 3 I have two options, either I can include 3 after 1, or I can include 3 after this 2. So should I include 3 after 1, or should I include 3 after 2? Of course I should include it after 2. Why? Because 2 gives me the best ending and 1 gives me a second best ending. So of course I want the longest possible answer. That should be it should give me plus 1, right? So this will give me 3, right? Because I have included it after 2. Okay, again for this 4, 1 2 3, it can be 4, because then it will come after this 3, as 3 is less than 4. Don't get confused in indexes and elements. Okay, just follow this basic formula, this TP recurrence relation. Okay, now tell me about this 9. This 9 can be included after any of these numbers, because all are smaller than 9. So which number will give me the best ending? Of course this 4 is giving me the best ending. 4 plus 1 is 5, right? Okay, now let's talk about this 6. So this 6 can be included after 1, 5, 2, 3, 4. And after which number should I include it? That will give me the best ending. Which will give me the best ending? Of course this 4. So here it will be 5, because 4 plus 1 is 5, right? Again, now let's talk about this 10. This 10 can be included after every of these numbers, 1, 2, 2, 3, 4, 4, 5, right? 4, 5, 5. So out of all these numbers, 1, 5, 2, 3, 4, 9, 6, 10 is greater than all of these numbers, right? So what is the best ending that I get for 10, so such that I can place 10 after that? It will be which one, guys? Of course either 9 or 6, I can take any of them, right? So if I add 10 after 9, it's also a valid longest increasing subsequence, and if I add 6 after 10 after 6, it will also give me a valid subsequence, longest, right? So let's add them, and let me write it 6 over here, right? So see how have I made the transitions. We can even find the subsequence. This 10 has been, let's say, included from this 6, 6 from 4, 4 from 3, right? Because this 4 has came from 3, this 5 has came from 4, and this 6 has came from 5, right? Again 2, and this has come from 1, right guys? Basically I'm tracing back. See, if I made this 2, then from where did I get that 1? If I made this 3, from where did I get that 2? If I made this 4, from where did I get this 3, right? So it's about tracing back now, and we can easily trace it, right guys? So this was the first example to find the longest increasing subsequence in in an array, right? So basically guys, this approach will take how much time? O of n square time, because for every element what I have to do is I have to traverse back. I have to find for all the j's that are less than I, that means traversing back to the left, and I have to then check, is aj less than ai? If yes, then I have to take maximum of tpj, right? So for this we need a double for loop to do this work, right guys? This is the first example for to find the longest increasing sequence using dp1. I'll code this in the next video, and after that we'll go on with the better version of this, that is dp2. It's tricky, but it will also take O of n square time. But if you don't try to understand this dp2, then you won't understand the n log n solution of binary search. Okay, so let me write here the time complexities of all these. It's O of n square, it's also O of n square, but this is important to understand. For this, it will be O of log n, and this will be also n log n, right? Okay, we'll try to understand all of them one by one, right? So in the next video I'll code dp1. That is the standard way to find the longest increasing subsequence, right? So guys, now tell me, what should be the best answer for this? Is it necessary that the answer will always end at this 10? No, na? It's not necessary that answer will always end at this position, right? Why? Because let's say if it was not 10, let's say if it was 1, let's mark it 1. Okay, so 1 can be included without any other objects, right? It cannot come after any other element. So what will the best length over here? 1 only, right? Now, is my answer ending over here? No, because it's a subsequence. It can end over any index, whichever gives me the maximum value. So now I have these two indexes, that is 5 and 6. Those two indexes are giving me the best answers to end with, right? So don't think that the answer will always be dp of n minus 1, because we never know, na? The longest increasing subsequence may end anywhere in the given array, right? Okay, so let's code it. So guys, let's start with the code of this first dp1 standard solution, right? You can also code it yourself. So let's begin. Let's include the files. Right, so again I'm explaining, don't get confused with these lines. Okay, this is just to take an input from the input.txt file and write an output to the output.txt file, right? That are on the right hand side of the window over here, right? So let's give it some input. Input can be the length is 8, right? And what is the array? 1 5 2 3 4 9, 1 5 2 3 4 9 6 and 10. You can take any, right? I'm just taking the one that I explained. Let's take and input it, and let's make an array, right? Let's input this array, right? I've inputted the array. Now what I need to do is, for every index I need to make a dp array, right? So initially fill it with 0, right? Now let's start the solution. As I discussed, for every index, what do I need to do is, I need to go back. I need to start from 0, and for every j I have to go less than I, and what I need to check is I want the maximum of all the dp values, right? So initially we know the dp values is filled with 1. So what should we do? Let's take maximum of all the values. And now guys, there was another condition. What was that condition? That aj should be less than ai, right? So if a of j is less than a of I, then what I want is dpi equals to maximum of all dpj's, right? So basically right now I have taken a maximum for all these values. I haven't taken another variable, right? So don't get confused. I have taken the maximum of all these j values that satisfy my condition, and after that what I need to do is dpi plus plus, right? Because I have to add 1 to it, right? So taking maximum for all and then adding 1 is same as taking maximum plus 1, right? So it will be how much? Let's take maximum for all, dpi comma dpj. Or you can, or what you can do is, you can also write it like this. Anyway guys, okay, I hope it's clear to you all, right? So let's try to print this array. Right, let's check for errors. Okay, right. So basically what I have here is dpi equals to, if aj is less than ai, okay, j equals to 0. Shit, there are some mistakes that just don't go right. What I have here is, okay, So guys, as we all know, we are getting a wrong answer over here. Why? Because see, this dp value is filled with 0, right? So what can we do to fill this dp value with something else? Initialize dpi as 1. Why I'm initializing dpi as 1, guys? Because everyone can end at their own positions na, with length of 1, right? Every element can end at length 1, right? Because of length 1, every sequence is a longest increasing sequence. So we got this array that we already discussed about, right? So what is the my final answer? The lis, longest increasing sequence. So the longest increasing sequence will be the maximum of all these values, right? dp cout lis, right? We can also take it as 1, right? Don't worry. So basically we don't have to initialize dp n by 0, we have to initialize it by 1. Why? Because every element can give me an ending at 1, the element itself. Okay, so here is an O of n square solution to find the longest increasing subsequence, right? Okay, after this we'll move forward. So hello everyone, let us see the second method to find the longest increasing subsequence. The first one is done and we have also coded it, right? So let us see the second dp method, and it's a slight tricky method, but yes, of course we'll get it, right? So in the first, what I did was dpi represented the length of the longest increasing subsequence ending at I, right? So this state represented this, right? But now let me change my state. Let's change this state. Now this dpi will represent the element at which the length of, or let's say at which the subsequence of length I ends, right? So now my dpi is actually the element. Dpi will contain a value. That value will be a value of an element from the array at which the subsequence of length I ends, right? Basically now I is a length. Earlier this I, it was an index, right? So we used dp of n in the earlier above approach, right? For this approach, what should be the length of the array? It should be dp of n plus 1. Why? Because we can have subsequences from 0 to n length, right? Where n is inclusive. Okay, so here I represents length. Again guys, I'm repeating this, it's very important to understand this. dpi represents the element at which the subsequence of length I ends, right? Earlier what it was, the length of the longest increasing subsequence ending at I. Here it is the element at which the sequence of I ends, right? So we can see that there can be various elements to which the length of let's say this one only, length of 5 ended at 9 also and 6 also, right? So what should dp5 contain in my newest example? Because we can see now there can be different ways, there are like different elements at which length I, lis of length I ends, lis of length I ends, right? So out of all those different elements, which element should be my optimum to use? Of course the lowest one, right? The smallest one among them. If my lis is ending at 9 and is of length 5, if it is also ending at 6 and gives me a length of 5, then dp of 5 should contain 6, right? Why? Because we won't take 9, because let's say if I get 7 afterwards, then I can easily say na ki dp of 6 can represent 7, right? Because dp of 5 was 6. But if I took dp of 5 as 9, that means the length of 5 was 9. The element at which 5 ended was 9, because I have both the options, you can see, right? Then after that I won't be able to add 7 to length of 6, because you will understand it, don't worry. I cannot add it to dp of 6. Why? Because if dp 5 length of 5 ends at 9, then length of 6 cannot end at 7, right? So this 7 will become useless for me if I take 9 over there. Therefore I have to take 6 over there, right? So out of all those elements, what I want is the smallest among them. Okay, just let me write it over here. If there are various elements at which it ends, right, out of those various elements, what I want is the smallest among them, right? The smallest among them. I hope it is clear to you why. We can easily take a new example. Okay, I'll explain to you why, don't worry. Let's see how this dp works, right? After that you will easily understand like why am I doing so, why I'm taking the smallest among them, and like ये सब चल क्या रहा है. Okay, we'll understand this first. See, what I'll do is let's make an array, and let's take a good example, 1. Then let's take an example 5. After that let's take 1 4 here, and then 6, right? Or and let's take 1 2 also, 1 5 2 4 and 6, right? So let's say this was the array, right? Now let's make a dp array, the one I talked about you right now, right? So guys, this should be how much length, because in the worst case the length can be n if all the elements are like this, 1 2 3, like increasing sequences, right? So we have to take the dp of length n plus 1, so that I can also index. So what is the length over here? 1 2 3 4 5. So 0 1 2 3 4 5, right? So let's take this. It was bad, right? Okay, now I have made a dp array. It's very important to understand this algorithm, guys. What is happening over here? Okay, see, first of all what I'll do is I'll fill some very small value on the zeroth index, because the length of 0, I want every element to take the place of 1, right? And how will it take a place of 1? I'll show you. Let's fill it with some very small value, minus 1e9. Okay, and let's fill all the other values with plus 1e9. What is 1e9? 1e9 is 10 to the power 9. Okay, I hope you all know about this much, right? 1e9. Now what I'll do is, for every length of an LIS, I'll try to add an element, right, which will give me that particular value, the dp value, right? So let's try to add this one. So guys, what should be the length of LIS ending at 1? The length of the LIS ending at 1 should be how much? 1 itself, right? Why it is 1? Because see, dp 0 is how much? Minus 1e9, and dp of 1 is how much? 1e9. So guys, this 1 will be included between these two values now, right? If right, because if I include 1, then of course it is greater than the value and value ending at length 0, and it is less than the value ending at 1, right? So if it is less than length 1 and it is greater than length 0, then I can easily add it at length 1, right? Try to understand this. Let me just make one small change over here. So basically this will become 1, right? See, now dp1 contains 1. What does this mean? That the length of 1 is at 1. Okay, After this, let's try to move on to 5. Okay, so if I'm at 5 guys, then this 5 should be at which two positions in this DP array? That means this 5 should be less than some DP value and should be also greater than some DP value, right? DPi and DPi plus 1. What does this mean? That for a particular length of I, if I try to place 5 after that, right? Because DPi contains a particular number, so I can easily place 5 after that DPi value, right? So what I want is the smallest I such that 5 can easily be included between those two values, right? So guys, what is the smallest I that I get is, see, 0 1. Can 0 and 1 be? Does this satisfy this condition? No, right? So basically this 5 should come after which position? One between these positions 1 and 2, right? Why? Because dp1, that means the value with which length of 1 ends, the best ending of length 1 is at 1, right? And 5 is greater than this 1, right? And 5 is less than the best ending of 2, right guys? If 5 is less than the best ending of 2 and it is better than the best ending of 1, then it should come to the best ending of 2 to give it a better ending, right? 5 will come over here, right guys? So I hope you just come back here again and read this: elements at which the subsequence of length I ends. Okay, and out of all those different elements, I'll take the smallest one, right? Let's move forward and then you will see the different cases. Now guys, let's come on this 2. Now here we'll tackle this case, these two cases. Okay, again for this 2 guys, this 2, where should this 2 come? This 2 should be after a value that is greater than 2, right? Basically again using the same method, that for a particular dp of some length, this 2 should be greater than that, because this represents a value, not a length, right? And it should be less than dp of length plus 1. Why should it be less than dp of length plus 1 guys? Think about it. Because see, if there is a value, let's say there is a value 1 that ends over here and there is a value 3 that ends over here, then 2 can come between them, na? Right? Okay, let's try to understand this. So again what I have to do is I have to find such a length that 2 is less than that length and it is less than the dp of length plus 1, right? So again I'll see that I have got this place only 1 and 2. Why? Because dp of 1 is less than 2 and it is less than dp of 2, right? So best ending at 1 is at value 1. I can easily place 2 after that, right guys? And this 2 is less than 5. What does this mean now? That I'm getting 2 places which will give me a length of 2. First place is 5, which is at index 1, right? And the second place is 2, which is at index 2. So guys, should I not replace this 5 by 2? Tell me. Of course, because now I have 2 possibilities, na? This 2 also takes an ending at length 2 and this 5 also takes an ending at length 2, because they both are coming after 1, right? So if both of them takes an ending at length 2, then which one should I give ending at length 2? Of course 2, right? Because for this 4, then I'll take 2 as an ending at 2 and upgrade that 4 into 3, right? Otherwise if I keep on updating 5, means I leave 5 as it is over here, then I won't be able to update 4 over here, right? But if I update 2 over here, then I can easily update 4 over here, right? Because 1 to 4 will give me a length 3 subsequence. I hope I'm making sense to you right now. Okay, so basically what I'll do over here is that I found a position and we can easily see that at this length we have a value 5 and which is greater than 2, right? Let's update 2 over here. Okay, so there were 2 guys that can come over this place of length 2 at dp2. that were 2 and 5. So which one should I take? The smallest one, so that I have more future options, right? Okay, now let's come at this 4. Again, what we'll do is we'll try to find a particular length for which this can be included, 4 can be included, right? Let's find a particular length for which that this value is less than 4 and this value is greater than 4, right? So again, does 0 1 satisfy? No. Does 1 2 satisfy? No, right? Because 2 is less than 4. Does 1 3 satisfy? 2 3 satisfies? Yes, because dp of 2 is how much? 2. Because length of 2 ended at 2 and length of 3 ended at some very greater value, because that's why I've taken that greater value, so that I can easily mark them, right? We have to fill the base cases in such a way so that 4 can come between 2 and 1e9, right? Okay, so this 4 and this is 1e9, right? dp2 4 dp 3. That means here for a length of 2 I have the best value to be 2, and I can easily place 4 after this 2, right? So what I'll do is at ending at 3 I'll place 4, right? So the best length, the best value that ends at length 3 is 4, right guys? Because it can easily come after this 2 and this after this 1. So we can easily see that this array will be increasing, or in our case it will be strictly increasing, right? I hope you can easily see this, that why would this array be increasing? Because I'm using this condition. I'm finding a particular length value, that is an index value, and for that length value I'm trying to find a particular position in which I can easily insert my element, right? So this will always give me strictly increasing array, right? Because of these two inequalities, right? Because of these two comparisons, this will always be a strict increasing array. So let me just write 6 over here. Again guys, what is the best ending at 6? That what should be the best length that should be at 6? Again, we'll go over this dp value and we'll try to find a length value for which the 6 would end, right? So the 6 can come between 4 to 1e9, right guys? So I'll update 1e9 as 6, right? So basically what I have got is that at length 4 I have, don't get confused over here. In the previous dp value, what I was doing is I was marking dp as I as an index, that this is the index and for this index this is the length. But right now I am just doing the opposite. Right now what I am doing is that I is the length and at dpi is the value, right? So for a length I plus 1, the value will always be greater than the value at I, right? Then only it will be a strictly increasing subsequence, right? So dp I will always be less than dp of I plus 1, right guys? For this, what answer we do have? For length 0, no. For length 1, yes. We also have a length 2, length 3 also, and length 4 also. But we don't have an answer for length 5. Why? Because it is 1e9 only that we filled initially. It has never changed. There is that no value occurred, right? That could change this dp5 position. Okay. I hope I am making sense to you over here. This is really very tricky, but it's not that hard to understand. Okay. Okay, let me take one more case. Actually what is happening over here is guys that for a particular length I am trying to add that value in a length, and I'll only add that value if it is smaller than already added value, right? So I hope you got why I removed 5 and updated with 2 over here, because if I have updated 5 over here, then guys 1 and 5, and after this I cannot add 4, right, at the third index. But the best ending at 4 will be of 3 only, right guys? 1 2 and 4, right? So it was optimal to place 2 over here. This was a little greedy. Like for all the possible ways why I am taking the smallest one to give me more better options in the future, right? If I upgrade with 5, I cannot upgrade with 4, but if I upgrade it with 2, then I can easily upgrade it with 4, because I want this to be strictly increasing, right? Okay, I hope you got this. So what I am doing over here is I'm trying to find a possible place of a element such that that element is just greater than the previous element, right? That means for a ai value, that is an value of an array, I am trying to find a dp, a position, right, such that it is less than ai and dp position plus 1 is greater than ai, right? So how to find this position, guys? We can easily iterate over all the positions and check for a particular position, right? Now I hope you got why was I initially filling 0 with 1e9 minus 1e9, because for length 1 anyone can take that position because it was filled with 1e9, right? Because all the elements will lie between minus 1e9 to 1e9, right? And out of all the elements, which one will give me the best answer? The one with the smallest value. See, let's try to run it on another example first, then we'll move on to code. Let's take this example 1 2 3 4 5 6. Okay, simple example. Initially fill the dp value. Okay, right. So what should be the length over here? Right, 0 1 2 3 4 5 6. Okay, coming on to okay, initially filling it with minus 1e9 1e9 some greater value, right? Now what we'll do is we'll always try to find some position value such that dp position is less than ai and dp position plus 1 is greater than ai. So guys, when I'm on this one, when I'm on this one, right, where will this one come? Between these two values, right? Why? Because any number can come between these two values, minus 1e9 to 1e9, right? Because this will be minus 1e9 and this will be 1e. Any number can come between them because I've already taken them in such a way, right? So let's place 1 over here, replace it by 1. So the best length of 1 is 5, right? Now at this 2, guys, where should this 2 come? This 2 should come where? Over between these two values, right? This 2 will satisfy these two values, na, dp1 and dp2, right? Why is this happening? Again I'm saying that for a length of 1, the best value is 1, and after this one I can easily add 2 because we are iterating from the left, and this length value is 2, right? So for this length, if it is 1 and I have 2 right now, so I can easily upgrade it on dp length plus 1, right guys? Okay, so let's just make it, let's just change it. This will give me 2, right? Again the similar way, this 3 will give me 3 over here because 3 will lie between 2 and 1e9, right? And this 4 will give me 1e9, it will lie over here, 5 will lie over, and 6 will lie between these two, right? So what will be the best answer for all these length values, which has the answer not equal to 1e9 that I already filled, right? So 6 has the answer not equal to 1e9, so this will be the best answer, this length 6, right? I hope you got this, why I have 6 over here. Now let's take a reverse case and try to understand what is happening over there. The reverse case can be 6 5 4 3 2 1, right? And let me just make a dip array, right? This is 0 1 2 3 4 5, and let's say initially I'm on this, let me fill it. Initially I have filled with the values that I wanted, right? So I want for this 6 I want the best place to where it can easily fit, between 0 and 1. So it is greater than with a value that is 0, so it will make this change to right. So this 6 gives me the best ending for length 1 right till now. Now guys, this 5, where should this 5 lie? This 5 also lies between 0 and 1, right? Why? Because dp of 0 is less than 5 is less than dp of 1, right? Because at dp of 0 we have minus 1e9, 5 is less than 6. So guys, this 5 should give me the best ending for 1 now, na? Because if I take this 6 as the best ending, then there will be less future options than placing 5 over here, right? Let's place 5 over here. Again, moving on to this 4 will also come between these two values, right? Again, I'll replace it this 5 by 4. I hope you are getting me. Why am I doing so? Let me again explain you with a very simple example. So for all these values, what will happen? All these values will take position 1 only, 3, then 2, then 1, right? So finally, what will be my answer? This cannot be my answer. No change. Okay. No change, no change, no change, no change, and no change. This was the one with the highest value and with the change, right? So the length of LIS is 1. Okay. Now let me give you another example. Okay. So many examples. You can also make one example yourself and try to run it. Why am I trying to find a particular length value for which dp of length will be less than ai? Because dp of length contains a particular value, right? If that value is less than the ai value, then I can easily add that ai value after that length. That means at length plus 1. Okay. Let's take a small example right now to understand why am I replacing things. Okay, let's say this 2, 5 and 4, right? 0, 1, 2, minus 1e9, 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 1e9. So for this 2, or should be taken reverse example, 5, 2 and 4. This 5, it should come over the place 1, it will have the length 1, right? This 2, this 2 also lies, okay, here it will be 5. So this 2 also lies between the position 0 and 1, right guys? Because minus 1e9 is less than 2 and 5 is greater than 2. So what's happening is, see, this 2 also ends at 1, that means it will also give me a best answer at 1. This also ends at 1, that means it also gives me the length of LIS as 1. So out of these two possible options, which option should be kept at 1? Again, if I keep 5 only, then guys, if I keep 5 at 1, then for this 4, it will also come between this only, and then 5 will be updated to 4, right? But if I keep 2 over here, keeping 2 over here will give me more possible options to for a length of 2, right? Because if I keep 5 over here, then elements greater than 5 can come at position which dp2, right? But if I place 2 over here, then elements greater than 2 will come at position dp2, right? So which is better? This is giving me more options, right? Because this is also giving me an option of 3 and 4, right, with all the other elements. So I hope you got me. Why is this happening, right? So here I'll replace that with 2, and here I will change it to 4. Okay, because for 4 then I'll have these two places. I hope you got me. Why am I doing so, and why I've taken such a base case, and why what my DPI represents. It's tricky, but it's not tough. Okay, tricky, but it's not tough. I've taken different examples. Length at which the subsequence of length I ends. Element at which the subsequence of length I ends. Okay, and out of all those different elements, I want the one with the smallest one, because for future I want better options, more options. Okay, right? So after this video we'll code it out, right? So thank you. So guys, let us see how to code it, and let's try to find the time complexity of DP, the second method, right? And then after that we'll see some better observations. Then by using that observation we'll optimize it. Okay, right? So let's take this example only. This was the above code. Let's remove this. Okay, right. So in this DP, what we want is the value to be n plus 1, right? Because we want all the lengths from 0 to 0 to, right? Okay. So what was my initialization? The base cases, the things that I initially filled the DP value. So let me just fill it. For I0 to n, what I wanted DP, okay, from 1 to n. I wanted DPI to be something really big, int max, right? And what should be my DP0? DP0 should be something very small. Let's take it as int min, right guys? So the 1e9 and minus 1e9 is actually int min and int max over here. Now after this, what I need to do is, let's try to iterate over all the possible values of this array, right? And now I have to find a particular length. Okay, let's find a particular length for which my condition holds. This condition holds, right? This position, let's take a position or a length, name it anything, right? So length 0 to length n minus 1, and I want this position to, this condition to hold, right? For all these length values, if dp of length is less than ai, first condition, and what should be the second condition, that this ai should be less than dp of position plus 1, right? So dp of length, or let me write it like this, ai should be less than dp of length plus 1. So what will I do over here is, I'll simply mark dp of length plus 1 equals to how much, ai, right? So out of all the possible values, the one with the smallest ai will be updated, right guys? Because let's say 5 was updated over length plus 1 and 1 was updated on the length. So if I got 2 now, let's say ai was 2, then dp length is 1, it is less than 2, and 2 is also less than 5. So dp length plus 1 will be equal to ai. Why am I doing so? Again guys, I'm repeating the same thing. It's tricky, but it's easy to understand that after 1 I can add 2, right? So if that 1 gives me an best ending till now, then I can easily add 2 after that, right? Right now I'm actually maintaining a subsequence in my dp value, right? I'm actually maintaining a longest increasing subsequence, that if this is the value, then this can come after this value, right? So this dp value represents actually a subsequence. Okay, I will also print it up for you all, don't worry. Now in the end, what happens is, for all the lengths I check from 1 to n, and for all these lengths guys, if dp of I not equals to int max, then let's take a variable lis, let's make it lis equals to, right? So the largest one will automatically override the lis, right? So let's just print ls, right? 6. So I hope this is clear to you. Let's take another examples. In the dp array, we are actually building a lis. Okay, so let me just print this dp values, okay, before and after performing those operations, so that you can easily understand it. Okay, let's one more thing. Right, print cout dp length. Let's mark and let's take it equal to, right? Okay, so actually the int max is taking a big value. Okay, wait then. See, initially what I have is, at 0 I have int minimum, and all the places I have int max, right? Now as this 5 comes, and this 5 will be between these two positions, right? Between int man, int max, int min and int max. Why? Because I have placed them in such a way that any value that comes takes the first position, the length of 1. First this will be filled, right? Let me take another example. Right, see, for 1 2 3 4 5, what's happening? Initially 1 is filled over here, right? Then 2 is filled over on the second place. Why? Because 2 comes between these two values, right? Again this 3 comes between these two values, and then I place the 3 over the length, right? I hope you got this, right? So in the next video we'll see n log n solution to finding a longest increasing subsequence, right? Okay, so guys, thank you. Hello everyone. Now let's try to make some observations to find the longest increasing subsequence in n log n. So I hope you got the dp2 method. In the dp2 method I am actually building a longest increasing subsequence in the dp array, right? So right, so guys, we all know that this will always be strictly increasing, right? dp position to dp ai to dp position plus 1. I mean that the dp array will always be strictly increasing, right? If you remove the base cases, of course. Whenever there is a value filled in the dp array, then the whole array should be always strictly increasing, right? Because I am actually finding such a position such that this position is greater than ai and this is less than ai, and I'm updating dp position plus 1 to ai, right? So this will ensure me na ki it will always be strictly increasing. Why? Because ai is greater than position, and then position plus 1 is equal to ai. That means that dp position plus 1 is greater than dp position, because ai is greater than dp position, right guys? If this ensures me that it will always be strictly increasing, then this monotonic order of the dp array, let me write it, monotonic order. There are two ways to understand this. That first is ki the one I explained right now, this one, that this proves that it will always be strictly increasing. And the second is that if you really went to the depth of the algorithm, you will see that I'm actually trying to build a LIS in the DP value, right? So DP values actually build an LIS only, the longest increasing sequence, right? So it is of monotonic order, right? We can prove this by two ways that I already explained, that why it will be a monotonic order, always increasing order. So if this is a monotonic order, then this gives me a advantage to use a binary search over the values, right? It gives me an advantage that I can use a binary search to find particular position such that ai is greater than position and dp position plus 1 is greater than ai, right? I can easily binary search because it's an strictly increasing array, right? Let's say the array is 1 3 5 9 and 15, and I want to find a position, this position value for 10, right? So what will be this position value for 10? Of course 9. Between 9 and 5 I can place 10 over here. How can I get this position value, guys? Because I have the first number that is greater than 10, that is 15. this is the first number that is greater than 10, right? So this is smaller than 10 because it's strictly increasing, right? And then what I can place 10 over here, right? And if I place 10 over here, I'm replacing 15 with 10, right? Right. So if I want to find for the 4, I can easily binary search for that, right? I just have to find the next greater number that is just big than 4, that is just greater than 4. How can I find that in a already sorted array? By applying upper bound. If I have to find just greater number than any other number, I can easily do it by finding an upper bound, right? So if I try to find an upper bound for 4, it will return me this position that is pointing to 5, right? And I can easily change it by 4. Why? Because 5 is greater than 4, and of course 3 will be less than 4 only, na? That's why upper bound is giving me 5. I don't have to worry about 3 now. Otherwise, if it was greater than 4, then this was my upper bound, and it's strictly increasing, that I have already proved to you, right? Basically what we'll do is we'll use the upper bound function to find out the position, right? So the thing that we were performing over here, let me just move this second. Yeah, what I was doing here, I was actually trying to find for every a I was trying to find a particular position at which I have to update it, right? And guys, if the array is strictly increasing, I will only have one position, na, between which 4 can occur. There cannot be more than one position at which this 4 occurs, right? Between those two values 4, there is 4, right? So basically, if there is only one position at which 4 occurs, and that also I can easily found it by upper bound, right? Because 4 cannot come here, not here, not here, it will only come here, right? Because it's strictly increasing, and this gives me, strictly increasing gives me how many? N minus 1 ranges. Out of these n minus 1 ranges, there will be only one range in which 4 lies. Why? Because all of these ranges are disjoint, right? Either you understand it this way, or you can understand it your way, right? Because all are disjoint, then there will be only one particular length that will include an element ai. Okay, so what I'll do is I'll use the function upper bound to calculate this index, that is the position plus 1 index. And then what we'll do is I'll just update this position plus 1 index, right? So how will I update this position plus 1 index? Try to make it yourself first, and then I'll explain it to you why is this happening. Try to code it yourself first, okay? I just have to find a particular position, and then I have to update this value with a given different value, okay? And this is always strictly increasing, right? Why is this strictly increasing? Because already I have told you why would this be strictly increasing, right? So let's code it out. For this, what I can do is, let's try to write a upper bound function. Okay, let me just comment it out. Let's go for all the I values, right? And for all these I values, what I'll do is, let's try to find an index that will give me an upper bound. So let's take length value only, length, right? So what we'll do is, let's try to find this index or length, anything you say. So let's use upper bound function. I hope you are very aware of the upper bound function, right? Okay, so this is a static array. I have to use dp comma dp plus n plus 1, because its length is n plus 1, and I have to find the upper bound of a value ai, right? And minus d. So this will give me an index, right? At that index, I have to update it as the same way as I updated in the previous loop, right? So I found an index, and that index is just greater than the current value, right? So what I'll do is just update it. So if dp of length minus 1, if it is less than ai, just copying it from the above, right? and dp of length is okay, ai is less than dp of length. The second thing is ensured. Why am I checking the first thing? Because I want it to be strictly increasing, right? That's why I have to check it. Because see, if let's say 5 is already updated and the next position I have 6, then I won't update 5 on 6. Why won't I update 5 on 6, guys? Because I want strictly increasing array. That's why I am applying this condition. Okay, I hope you got this. Let's say for a particular value 5 is already updated and the next was 6 in the dp array, right? And I'm trying to find the upper bound for 5. So upper bound for 5 will give me this value 6, right? But can I make this array as 5 5? No na. Why? Because I want them to be strictly increasing. So I have to check whether the previous one is smaller than the value that I am updating or not, just like the previous example, right? This above example. So dp okay, don't get confused. Here I have taken length and length plus 1. I am updating on length plus 1. Here I have actually found out that length value itself, right? So dp length equals to how much? ai, if this condition satisfies. Okay, I hope this is clear to you all. Now again, how to find the lis? If dp I not equals to int max, lis equals to n. This won't change. Okay, let's print the lis 5, right? So I hope this method is clear to you all. Why am I applying binary search on it? Because using the advantage that it will always be strictly increasing. If it is always strictly increasing, the array is monotonic. I can easily find out the particular position at which I can place my current element, if it is placeable. If it is not placeable, then I won't place it, just as is in this example. I cannot place 5 at, I cannot replace 6 by 5. Why? Because I already have 5 over here, right? So thank you guys. Hello everyone, let us try to understand how to find longest increasing subsequence using dynamic programming with Fenwick tree and segment tree, right? So you can either use Fenwick tree or segment tree for that purpose. Both of them will work. I'll explain you why, right? So first of all, let us understand how this solution will work, right? So guys, please don't get sad if you don't understand it in one go, right? You may watch the video again, right? So what I can do is, see, for here I'll talk about the dp1 approach. That was the most simplest approach, right? So dp1, what was it representing? dpi was representing, see, what is the length of the longest sequence terminating at that position, right? Length of longest increasing sequence terminating at that position, the normal dp1, right? Terminating at that position, right? Or terminating at I. So this is what dpi represents, right? The length of the longest increasing subsequence ending at that I. Now guys, to calculate dpi, what did I need? It has already been discussed that I need the maximum of all dpj such that, plus 1 of course, such that j is less than I, right? And aj is less than ai, right? Both of these conditions should be satisfied. So guys, for all j less than I, what does this mean? That for any index I want the maximum from a particular range, that is from 0 to I minus 1, right? That's what j less than I means. This value j, it ranges from 0 to I minus 1, right? And for all these values, what I want is maximum of all those dp values, right? So how to find maximum for all those dp values? we can build fanbit tree or segment tree, because fanbit tree will also work here. Why? Because I'm trying to find the maximum from some prefix, right? So we can build other tree to find the maximum, but we have a problem here. The problem here is that aj should also be less than ai. For only those values of aj, we have to find the maximum of dpj, right guys? This is important, na? The second point, that okay, in simple english what I can say is, for all the values from 0 to I minus 1, all these values of dpj, which values do I need such that aj is less than ai, right? So this part, finding the maximum part, can be done by segment tree or family tree. But how to tackle this part, that aj should be less than ai and I want the maximum of only those? So guys, to solve this, what we'll do, we'll move in an order. Please try to understand this. We will move in an order and try to update those things, right? So if I say that from 0 to I minus 1, in this range, if only dpj values of the elements are updated, if a of j is less than ai. What I'll do is, I'll start from the smallest number, right? I'll start from the smallest value of array, and then I'll find the maximum from the left, and then I'll update the current dpi with maximum from the left plus 1, right? If I repeat this step again and again and starting from the smallest number, why am I doing so? Because if I am at a current index I, right, and all the smaller numbers have been updated and also updated in the segment tree, then what I need is, I just have to find the maximum of all of them, right? Because in the segment tree from 0 to I minus 1, only those values have been updated that are less than the current value of ai. Okay, let me just give you a quick example for this, right? See, let's write something: 3 2 1 9 5 10. Okay, so this is array, normal array. Will be more clear with an example. The most important thing is moving in an order, because moving in an order will ensure me that only the numbers that are smaller than the current number are updated, right? So let's say this is dpi value. Okay, initially fill it with 1 or 0, doesn't matter, right? Now, right, so let's fill all of them with 0 initially. Okay, right? So guys, what I'll do is, I'll just make pair of these array values and I'll sort them in ascending order. Okay, so first of all, at which value will I go? I'll go at 1, right? So currently I'm talking about this index. So is what is the maximum lis? Okay, let me write it over here: 1 2 3 5 6 9 and 10, right? So if I've sorted them, then I'm at here first, right? I'll go in an order, and this order means that I'm moving in an ascending order, right? So carefully observe the changes in the dpi value, right? See, if dp currently I'm on 1 and I'm at this index, I'll make a pair of index and value, right? Don't worry about that. So this index has the least value. Now guys, what should be the value of dpi over here? The dpi should be how much? The maximum from the left plus 1, right? So update it by 1. Maximum from the left is 0, right? After that guys, moving on to the second position, what does this 2 represent? This index, right? Now think that all the elements of less than 2 are updated, right? All the values of elements that are less than 2 are updated, right? So if you can see that what I need was, see, I wanted these two conditions. that j should be less than I. This can easily be handled of finding the range maximum query. And how to do this? If aj is less than ai, I have only updated those values. I only updated those indexes in which the value was less than the current value, right? Because I'm moving in an order. Okay, let me just move with this example and you will also understand it more clearly. It's quite tricky, it's quite like confusing, but try to understand it. Moving in an order solves various segmentary problems, even inversion counts. Okay. You can try inversion count yourself by that. It's a new topic, but please try to understand it. See, now I'm on the second element, the second highest element. So the second highest element, what's the leftmost maximum? It's 0 only, so updated by 1. Right, again the third one will be 1, similar way. Right, now guys, now I'll reach at 5. Right, so when I am at 5, I'm on the current, I'm on this index. See, now I want the maximum of this range. Why I want the maximum of this range? Because I want the prefix sum. Right, and guys, what will be the maximum from this range? It will give me 1. Right, why? Because this 9 was not updated. This is the most important part. This 9 was not updated. Why? Because it is after 5. And why it is after 5? Because I have sorted it in ascending order. So all the values less than 5 have been updated in the DP array. Right, if all the values less than current value is updated in the DP array, that value may be, guys, on the right hand side and that may be on the left hand side, but we only want the maximum from the left hand side, right? 0 to I minus 1, because smaller values can be anywhere in the array, right? We only want the answer from the 0 to I minus 1 values, maximum of all those values that have been updated. And which of the values have been updated? All the elements that have value smaller than the current element, right, guys? So for every index, for every value, what is happening? All the elements have been updated, the best endings, right? dpi has been updated and I just have to find the maximum in a given range. So for this 5, what I have is, let's find the maximum in the given range. This is the range, right, for this 5. So what is the maximum? 1. So 1 plus 1 is 2, right? So I'll update it by 2. Right, guys, I hope you got why am I not using this 9 and 0 over here. Because 9 is further to be updated, its answer has not yet been calculated. Why? Because we don't need its answer to make the answer of 5. That's why I'm going in an ordered way, in ascending order. Right, now let's talk about this 6. Right, after 5 is 6. Right, so guys, for this 6, again what I want is, I want the prefix maximum. Right, so this is the prefix maximum. Let's find the prefix maximum. What is the prefix maximum? 2, this position. So this 5 gives me 2, right? Again this 9 gives me 0, because for this 6 I don't need this 9. I can use 5, I can use 3, I can use 2, I can use 1, but I don't need 9. So basically what is happening, when I am trying to access some elements, I'm trying to build some elements DPI value, then for that value I want to find the maximum in the range 0 to I minus 1, right? And only those values have been updated in the DPI, the DP array, whose value is actually less than the current value, right? Only 1, 2, 3 and 5 have been updated. Only, guys, 1, 2, 3 and 5 can give me the best endings, right? 9 and 10 cannot give me the best endings, whether they are on the left or on the right, doesn't matter, right? So again for 6, what I have is, the maximum is 2 and I'll update it with 2 plus 1, 3, right? So going in an order helps. There are various questions that will be done by going in an order, right? Now guys, moving on to the next, I have 9. So for this 9, guys, what will the best answer? The maximum from the range, that will be how much? 1 only. So I update it by 2, right? Now moving on to this 10, again finding the best maximum answer from the left, this, right? What's the max? 3. So 10 will give me 3 plus 1, that is 4, right? So I hope you got this. See, why am I trying to move in an order? Because what I'm doing is, I'm moving in an order and I'm updating the value. So whenever I'm at 6 I have already updated 1, 2, 3 and 5, right? So whether one be on the left of 6 or on the right of 6, it doesn't matter, right? If it's in the left, it will come in the maximum. If it's on the right, it doesn't matter to me, right? So whenever I'm trying to build a DPI value for any array, the values on the left hand side of the DPI, what does left hand side means? 0 to I minus 1. They have been filled, and out of those values which have been filled, whose value is actually less than the current value, because I'm moving in ascending order and updating then and there only, right guys? I hope you got this. Try to think about it, pause the video. It's a new concept, but maybe not new for some of you, right? So but using this concept can solve various problems, like various problems, right? Okay, so I've also tackled this second thing, this thing by moving in a order, right? Moving in ascending order, because only those values have been updated, only those endings have been updated whose value is less than ai. So whenever I come on ai, that means at a particular index, the value ai, I have already updated all the endings with the values of aj that are less than ai, whether be on the left or on the right side, right? If it's on the right side, it won't come in my maximum because I want the maximum from 0 to I minus 1, right? So I hope it makes sense to you. So this is the, I want prefix maximums, right? So prefix maximums can also be calculated by Fenwick tree and segment tree. So right now I'll use Fenwick tree, I'll code it in front of you and then we'll move forward. So you must already be familiar with Fenwick tree, okay, and segment tree. I'll code it in using Fenwick tree, and then you can code it using segment tree yourself, because we just have to find the maximum of a range. That's the basic thing that these data structures do, right? So okay, let's start. So let me just erase this, right? So I've inputted an array, and let me write a Fenwick tree. Let's take a structure called Fenwick, okay, and then we'll use it. So Fenwick tree contains a vector, right? So if you're not aware of Fenwick tree, you must first go through it, right? Because in this video I'm not explaining how Fenwick tree works, it's already given to you. Then let's initialize it, Fenwick tree, right, with a particular value of n. Okay, so this, let me just write it fast, is right, and f dot resize and comma 0. Initially let's fill it with 0. This can be this kind, right? Let's take two. So after this, what my function will be like add, right, or let's say update on x this value, right? So let's update on x some value. How do we do this? To make it one base index, it's pretty clear, right? Making it one based indexed, right? And then while x is less than n, what I'll do is f of x equals to maximum of f of x and this value, right? And what will my x become? X equals to x plus equals to x and minus x. You must be aware of the Fenwick tree, right? So this will be a void type of function, and then let's ask the maximum, like what's the max in a range, right? This will give me a prefix max. Let's say I want to find the maximum till x, increment x to make it one base index, that we don't get confused, right? And then what I'll do is while x, let's take some resultant equals to 0 only, because we want the max. Resultant equals to maximum of resultant comma f of x, right? And after that what I'll do is simple x minus equals to x and minus x. So this was simple Fenwick tree code. After this we'll see, we'll use this fan tree. Okay, so let's take fan pick, uh, and let's name it tree. Okay, so I've taken this structure. Now let's initialize this tree dot init and initialize the tree. Right, so guys, what all things that I need to maintain this solution? I want them to be in ascending order, and I also want that index, right? So for this array, what I can do is, let's make this array as pair of, right? So the first value can be this, and let's save on the second value the index equals to I, the index, so that I have paired up the values and indexes. And if I sort this array, then the values are in the increasing order, right? And the second value, that is the paired value, it's with that, right? So let us see if there are some errors. Okay, okay, wait, acha, this max has been overwritten, or let's say query. Okay, let's query it, otherwise that max will overwrite it in the structure, right? Query. So this error, right? After this, what I need to do is, I've sorted the array in the ascending order. Let me just take a good example. This only 3 2 1 9 5 6 10. 3 2 1 9 5 6 10. Right, 1 2 5 6 7. So 7. Right, let me just print it for you first. Cout ai dot first. It's a little advanced thing, but it's not that tough to understand how to go in order. See, I sorted this on the basis of the values, right? So if I iterate on this array, firstly I will on which index? Index 2, that contains 1, right? Because that is the smallest element. So guys, when I reach this index 4, which contains 5, before that I have updated all these values, right? And if I updated all these values, I just have to find the maximum answers. I've updated all the values that are less than 5, right? Okay, right, so let's just do it. Let's start iterating on this array, and value equals to ai dot first. Let me write it separately, and index equals to ai dot second. Okay, so for a current value, I have to find the largest, the maximum thing, right? The maximum prefix. Okay, so let's take dp, and what will be this dpi? So dp of something will be equal to how much? P of this index will be equal to how much, guys? Tree dot query. I have to query from index from 0 to index -1, because we know that fanbig tree always gives me the something maximum of prefix, sum of prefix, minimum of prefix, right? This will be maximum of prefix plus 1, and I'll just update on this index. I'll update how much? dp index, right? The value that I have calculated, right? So let's try to print out dpi values. Right, so guys, you can see this 1 1, why I have 2 over here and 3 over here and 4 over there. Right. Okay, let me try to print this dp values here only, initialize them with 0. Okay, so this should be j now. Right. Okay, see, initially one happened here, right? Then 1 and 1. Why? Because for any element, if I'm trying to find the prefix maximum, to find the prefix maximum, guys, we only need those values which are less than the current value, right? For that current value, I have sorted this array. right? So 1 there, and then 2 over here, then 2 over here, and 3 over here, and 4 over here, right? Okay, let me just take some other examples. 5, right? Think how will the DP values be filled? See, 1 1 1 1 1 1, right? So first it will go to last index, then this, then this, then this, and then this, right guys? Okay, let's take another example. We'll talk about time complexity, don't worry. See, 1 2 3 4 5, right? So first of all, this is the smallest element, then second, then third, then fourth, then 5, and we want the leftmost sum, leftmost maximum, right? So I hope you are getting this. How did I fill the DP values using Fenwick tree? So guys, this or let's talk about the complexity. So this is simple input. This sorting will take how much? N log n time, right? Then I have initialized the tree, nothing to worry about there. This DP array, nothing to worry about there. This query functions in how much? Log n time. You already know about the Fenwick tree, right? And after that, when I do a update function, the update call, it also works in how much? Log n at max, because it's a property of Fenwick tree, right? Okay, so what I have done is this loop, for this loop from I0 to I less than n, this loop goes till O of n time, and is all O of n time. I have updated a log n operation 2 times, right? So what's my total complexity, guys? N log n for sorting plus n into 2 log n for update and all that in the given loop, right? How much it is? 3n log n. So we can easily say it is O of log n only, O of n log n only, right? It is a constant. So in 3 of in O log n, I have finded out the LIS, right? Now what I need to do is I have to take the maximum for all the endings. Int LIS equals to 0, and then let's take the maximum for all these. Right, let's print the LIS PPJ, change it. So this was the code to just find the LIS using Fenwick tree or segment tree. See, in the segment tree there will only be just one little change. What will be the change be? That for the query I have to ask from 0 to I minus 1, but in the Fenwick tree, if I query, I just have to find till index minus 1, because Fenwick always tells me something from 0 to I minus 1, right? So this is one based index, right? And this is also one based indexing. Don't get confused. Or if you want to know more about the Fenwick tree, you can also go on this link. In the given link, I have explained the Fenwick tree I have used, cp.lk /cp 27 May. Okay, so you can go on this link and you can try to understand Fenwick tree first, and then how I have used the Fenwick tree over here, right? So guys, thank you for watching this video. I hope I have made all those 4 methods clear to find longest increasing subsequence in different complexity. The first one was basic. I used the first one in the fourth one, right? And the second one was quite tricky. I used the second one in the third one, right? Okay, so guys, let's try to find a fifth way to calculate longest increasing subsequence using longest common subsequence, right? So we know about longest common subsequence. It's a dynamic programming problem. It's a standard problem. We all are well aware of this problem and its solution, right? So let me just write it over here, right? So guys, basically we have longest common subsequence for 2 strings, right? If in a given string and a given string t, s and t, tell me the length of the longest common subsequence, and even we can trace it back, right? Now let us try to find we can easily convert this longest common subsequence that is in string to in this arrays, right? Let's take a array A and array B, and we can easily find the longest common subsequence of array A and array B, right? Because uh, we can easily find the longest common subsequence of the arrays also as the same way as the string, right? So guys, now let's say if I have an array A, and let that array be any array, okay, and I have to find the longest increasing subsequence of that array A, right? So guys, how can I find the longest increasing subsequence of A? If I make an array B such that B is sorted version of A, sorted A, right? If array B is sorted array A, that means I have two arrays where B is which sorted A, right? So if I try to find the longest common subsequence of both of these arrays, that will give me the longest increasing subsequence of the given array, right? I hope you get this. Yeah, let's say I am given this 3 2 1, right, and 1 2 3. What is the longest common subsequence of these two arrays? This is A array, so this will be B array because it's sorted version of A, right? For the longest common subsequence, 1, right guys? Let's take another example. 5 2 3 1 and 4, right? Let's sort it. 1 2 3 4 5. So guys, what will be the longest common subsequence? Longest common subsequence will be this, this, and this, right? Because I have sorted this array A into another array B, so this sorted array B represents an array of increasing numbers, right? So if I try to find the longest common subsequence of these two arrays, that will give me the longest increasing subsequence of the above array, because the second array is a permutation of the first array, right? This is B and this is A. So if I try to find the longest common subsequence of A and B, then I can easily find the longest increasing subsequence, because the longest common subsequence of A and B will be equal to longest increasing subsequence of A, right? Because these numbers are being matched, the subsequences are being matched, right? So that will give me an increasing array. I hope you got this, that why will I take B equals to sorted of A, right? Okay, I hope you got this. Right now I'm considering elements to be distinct, right? So think about it yourself. If the elements are not distinct, then we just have to make slight changes, not much to think about that, right? So I hope you got this. Let's code it out fast, or you can also code it yourself, right? Because we all know about the longest common subsequence, right? Let me just erase this, right? I've erased that array, right? And now let's just take an array A. Okay, so basically let's make a changes, right? Now as I said, I need another array B, and that should be sorted version of A, right? So just copy A in B, right, and after that sort B, right? So now B is sorted and A is not sorted. Now what I have to find out, I have to find out the longest common subsequence of A and B, right? Longest common subsequence of A and B, right? So let's write a function that will return me the longest common subsequence, right? So it will take array A, array B. Also these are arrays, so I have to pass out n and m values. The lengths, both of their lengths are equal. Let's just pass out n only, not m, right? Okay, right. So how to find the longest common subsequence, we all know, right? Let's make a dp n plus 1, n plus 1, right? And let's start with a double for loop, and very easy, we all are well aware of that. You can code it yourself also. So what are the cases over here? If I equals to 0 or j equals to 0, this is a case of an empty subsequence matching with another positive subsequence, right? So in this case, what I have is dp I j equals to 0, right? Else as what I have the case is that I and j are not equal to 0. What does this mean? If a of I minus 1 equals to b of I minus j minus 1, then if they both matches, then dp I j, actually I'm just coding it out because I think that each of you are well aware of this algorithm, right? Because it has already been explained in the course. That's why I'm just coding it out and I'm not trying to explain it. The explanation part is just this much, that if you have b as a sorted sequence of a and you find the longest common subsequence, then that will give me the longest increasing subsequence, right? So this is equals to how much? dp I minus 1 j minus 1 plus 1, right? Else what I have is dp I j equals to max of dp I minus 1 j or dp I j minus, right? Finally I just print out, or I'll just return the dp n, right? Okay, let's check for some errors. No errors, and we have got the answer 5, right? Take some different values, 3 2 1 2 3 1. So what's the longest? 2, right? So yeah, we got 2. So I hope you understood why I'm making a b as a sorted array. Okay, so what's the time complexity of this? Again, the time complexity to find the LIS is how much? N square, right? So O of n into n, right? So if this works in O n square and this sorting takes place in O of n log n, so basically the complexity, the upper limit will be how much? O of n square only, right? So this is an O n square algorithm to find the longest increasing subsequence, right? So I hope you got this. Thank you.